to the first problem related to the semaphore, which is a classical problem related to the semaphore. So we are going to understand here three problems. So the first problem is producer consumer problem. About the producer consumer we have seen earlier, but how we can solve that particular problem using semaphore, that we'll see. Next problem we'll see is called reader writer problem. That we'll see later on. And then we have a dining philosopher problem. The dining philosopher problem is also a problem, and that will be also solved by using semaphore. Okay, so there are three classical problem that was solved by semaphore. So let's talk about the first problem, which is called producer consumer problem. Okay, so first problem that we'll see is producer consumer problem. So we'll just write the procedure for that, that what is the solution for producer and consumer. And what is producer and consumer? Let me tell you that we have a critical section. Here, these critical section is nothing but buffer. Buffer is some sort of memory which is shared by both producer and consumer. So let's say this is C, which is a consumer, and this is P, which is a producer. So producer will always produce some data here, and consumer always consumes some data from here. Okay, that is a work of producer and consumer. How will synchronize these two, producer and consumer, so that there will be no problem at all? Means there is no problem of the this critical section. Means critical section problem could be solved. And we assume that the buffer is a bounded buffer. Bounded buffer means there is some limited size. Means the buffer size would be n, and n it should be some finite value. Let's assume that here n is 5, and we have 5, 1, 2, 3, 4, 5. We have 5 buffer size. One buffer size if producer is producing. Then another buffer size is if all the buffers are empty, then producer cannot produce further. And consumer will consume the buffer if there are no all the buffer are empty. So producer should not allow to, consumer should not allow to consume because it is empty. And producer will not allow to produce if it is full, right? And consumer will not allow to consume if it is empty, right? So these two are there. So in that, these synchronization we have to perform. Let's write this, the solution for that. Okay? Let's write the solution for that. So I'll write the procedure of producer first. So what producer is doing is, and make it true, right? You can make it 1 also. Producer function. So first it will make a wait on E, then it is going to wait on S, and then append. Append means it is producing something, it is adding something, and after adding it will make a signal on S, as well as it will make a it will make a signal on F, right? Let's go and write down for the consumer. While everything is true, producer will do operation on F, and the operation is wait. Again, an operation will be performed. It is on S. Then it will take means it will just take whatever it want to take from the buffer, and then there is a signal on S, and then there is a signal on E, and then just a function called use. Okay, so here what we have some semaphore. What are the semaphore we have? We have S is one semaphore which is initialized by 1, and it is for critical section. So S is one semaphore. We have another semaphore called E, and we'll initialize the value E with N, and it is for empty slot. So it will take care of empty slot. Again, we have a semaphore called F. We'll initialize it with 0. It will say that how many slots are full. So E is for finding out whether the slot is empty or not, and F is for finding out whether there is no slot, means slot is full. And here N is nothing but the buffer size. In this case, this value is 5. Okay. Now let's see how it is happening. Now let's say we'll start with the producer, and it is the first option is the weight E. Weight E means what is E? E is here 5. So the E value here it is 5. So when it will do weight E means we'll see that E value is greater than 0 or not. Is greater than 0, then it will decrement it by 1. It will become 4. Then it will do weight on S. What is the value of S? S will be initialized with 1. So the weight of S, it will become 0. Then it will append. Let's say some value has been appended, and the value is, let's say, 10. And then it will make a signal on S. If it will make a signal on it, this 0 will become 1. And it will become a signal on F. So F, previously it was 0, now it will become 1, because it will make a signal on F. Now what we have to take care here is, whenever the buffer is full, producer will not allow to produce anymore. And if the buffer is empty, the consumer will not allow to consume anymore. Let's say now consumer want to execute the code. Then the first one is weight F. F value is 1, so it can do a 0 here. Then it will wait on S. S will be 0 here. Then it will take means this value will be taken by the consumer. Then again it will be empty because it has been taken by the consumer. Then there is a signal on S, and there is a signal on E. Signal on E means this E value will be 5. E value tells us that how many slots are empty. F value will tell us how many slots are full. So how many slots are empty right now? 5 slots are empty. How many slots are full right now? 0 slots are full. Now let's see the problem. The problem is if it is empty, will not allow consumer to consume. So right now it is empty, right? Let's say consumer want to execute it. So it will go and execute its first code, that is wait S, sorry, wait F. And what is F? F value is 0. And because it should be greater than 0, then only wait should perform. But here it is 0. So wait should not perform. It will be in a busy wait. Means this code is not allow consumer to consume if buffer is empty. Getting it? Now let's see that. Let's assume that producer is producing, right? So the initial value here is, so I'll write it from the very beginning. And let's say we have nothing in the buffer. We have E value, which is 5, S value, which was N, and F value, which is 0. So let's say producer is producing, it is go for wait. E, wait A means it will decrement it for 1. Wait on S, it will decrement the S value of it and append some value. Let's say it has appended 0. And then there is signal on S and then a signal of F. And after that, again, producer want to produce. It can produce? Yes, it can produce because E value is 4 right now. It will make it to 3. Wait, it will make it to 0. Append, it can do append something. And then it will make a signal on S. And then it will make a signal on F. Because F is already 1, it will be 2. Now, again, producer want to produce. Yes, it can produce because empty slot are 3 right now. It will make it to 2. S value will become 0. It will append something. After append, it can signal something on S and signal on F. It will become 3. Can again producer produce? Yes, it can produce because the E value is greater than 0. Now it will become 1. S value will become 0. It will append something. Let's say 40 has been appended. After that, there is a signal on S and then a signal of F. Now, can again producer can produce? Yes, it can produce because it is greater than 0. Now it will become 0. Weight of signal S will be 0. Append, it can append. And signal F, yes, it will become 5. Now, can again producer can produce? Now you see E value is not greater than 0. If E value is not greater than 0, it will be in a busy wait. So here you can see that when the buffer is full, this code is not allow producer to produce. As well as we have seen previously, if buffer is empty, this code is not allow the consumer to consume anything. So you can see the producer consumer problem and the synchronization is maintained using this particular semaphore. And what semaphore we have taken? So S is your binary semaphore. And E and F are your integer semaphore. Right? So S is a binary semaphore which should have the value 0 and 1, and E and F will be the integer semaphore. With the help of that, we can solve a classical problem of producer and consumer. This is a solution for that. With the help of 3 semaphore, we can actually give the solution of producer consumer problem.